Hi, this video is to help you guys with your homework on Chapter 7, page 161 through 163 in Forensic Science for High School. You guys have been assigned numbers 1, 2, 5, 6, 13, 14, and 16, and this was assigned on April 20th. You're going to need to use Appendix D and E in your textbook, and those are located on page 172 through 177. So let's get started. Questions 1 and 2 are simple definition type questions. You will need to use EQ1 or EQ2 to define the differences between what is a controlled substance, what is an illicit drug, prescription drug, and over-the-counter drug. So that is question 1. That's, again, simply just defining and then contrasting those two. Number 2 is going to be located on essential question 2. What is a presumptive test? Also known as a field test. You should have already watched the video on Edpuzzle on field testing, and after that video you're going to know rather quickly when that field test can be used and what are the limitations, with some emphasis on false positive. So that Edpuzzle video and essential question 2 are going to help you answer question number 2. Question number 5 is where it starts to get tricky. So for question number 5, you can use your textbook. You can use Google. But first of all, I just want you guys to realize there are 3 parts to question number 5. So we're going to notice that we're asking you to find what is the electromagnetic spectrum. I want to know which end of the spectrum has the highest energy. And 3, how is it used for analysis of drugs? So again, 3-part question there. In order to answer that 3-part question, you can refer to these 2 slides. The first slide here is on spectroscopy, and it's going to define what the electromagnetic spectrum is. If you watch the video that I posted on Essential Question 3, it goes in detail what the electromagnetic spectrum is. If you simply just copied the notes, you're not going to get that explanation, so I would recommend going back and just watching it without taking the notes this time. But the first thing you guys want to know is the electromagnetic spectrum is going to be storing, basically it's a graphical picture that's going to show you guys how radiation is logged. So radiation is any type of energy that travels in waves. And those waves can be long or they can be short. So again, radiation is energy in waves. When we look at energy in waves, we look at something called wavelength. So over here on your electromagnetic spectrum, we're going to see 10 to the negative 6. So that 10 to the negative 6 is telling you that it is 1 million times smaller than the number 1. Okay, so the number 1 is located right here. This little black region right here is called the visible range. This is the range that you can see with your eye. So if you can see color, then you are locating the visible range on the electromagnetic spectrum. You're going to notice it's very small in comparison to this little black stripe, in comparison to the entire electromagnetic spectrum. So over here we have our little bitty gamma rays. We have teeny tiny X-rays. We know that we cannot see those with our eye without any type of assistance. And so their waves are going to be really tiny like this, very close together. And when we measure waves, we're going to measure them from what is known as peak to peak. So that is 1 wavelength, or trough to trough. This little bottom area right here, like a horse trough, that is 1 wavelength. Okay, so very, very tiny waves on this side. On the other side of the spectrum, we are going to see larger waves like TV and radio waves. We see microwaves, we see thermal radiation rays. And so those waves are going to have larger wavelengths like this. So we're going to get a lot larger. And again, we measure from peak to peak or trough to trough. And these actually from here to here, this area from here to there, and that area from there to there, they should be the same distance. Okay, so that's 1 wavelength. So our higher energy is going to be on the right side in this picture. Our lower energy is going to be on the left side. And when we're talking about higher and lower energy, we're talking about wavelength. So for our analysis of drugs, we are going to be using what is known as the infrared area. So this is the one I circled here in red. So again, watch that video and see why I circled that there in red. really important, but those are the wavelengths that we are using to do our drug analysis. And how do we do that? So when we look at this slide, you're going to notice that we are using infrared light. Again, we're using that area right here on the spectrum. This is just another type of spectrum to show you. Do want to notice that they are flipped. So on this particular picture, the little teeny waves are on this side, and those big fat waves are on that side. By blasting our drug specimen with that infrared radiation, that drug has two options. That drug can either absorb or it can transmit that radiation. So you want to make sure you know what the word absorb means. Think of things like sponges, think of things like towels, paper towels. What does it mean to absorb? So we know that when something absorbs, it takes it in. What does it mean to transmit? So if I have a transmittance, what that means is I'm allowing something to pass through. So in this particular case, our graphs are looking at transmittance. That means that we are looking at the amount of radiation that actually makes it through the drug. In these graphs, we notice they look a little crazy. There's all kinds of stuff going. There's a trough there. All kinds of peaks going on. Okay, so we know that in this particular graph, this is like a fingerprint. Ethanol, which is the same type of alcohol found in beer, whiskey, alcohol, things like that we drink, it will always produce this particular graph. So if you ever find a graph and you don't know what it is, and you get a graph just like this one, you can go to your appendix, you can go to your catalog, and you can match them up. And it's a simple matching game. Does it look the same? Yes, then that's what it is. Again, caffeine will always create that one. So we see down here it has those two peaks, right? So we kind of look at that, or two troughs actually. So we'll look at those kind of there to try to match. And so that's how we use it for analysis. We are measuring the amount of radiation that is either absorbed, but in the case for our textbook, we are actually looking at the amount of radiation that is transmitted. So that is question 5. And 6, actually. So what is the difference between absorbance and transmittance? Again, those are two words that you can look up on if you wanted to on the dictionary, or you could go to your textbook. So there's absorb. We want to make sure we define transmittance. And we know that their relationship is basically going to create that graph I showed you earlier. These two graphs here. And those two graphs are going to be like a fingerprint, where they are showing us the amount of radiation, in this case, that passes through the substance, and they're creating this fingerprint-like identification chart. So those are questions 5 and 6. For question 13, you are going to need to go to page 151 and 153 of your textbook. On page 151, you are going to find the field test, or the presumptive test, the color test. And so they're going to help you fill in this section right here. So if you read it, it says you have tested a sample of white powder with cobalt thiocyanate. That is a microcrystalline test. I didn't go over it too much in detail, but it is in the textbook. You just kind of need to know what a positive looks like. In this case, a positive they are telling you is blue. It's a blue precipitate. So we want to make sure, go to your textbook and find out what happens if you have a blue precipitate. So again, that's just quick match. But we know from the video that sometimes our field test can be wrong. So we're going to ask our lab to do a spectroscopy confirmation, and they're going to provide you with this graph. So you as a student want to know what type of graph this is. Again, we see that we have transmittance on our y-axis. We have wave numbers on our x-axis. We have what looks to be a continuous line. Crazy one that it may be, but it is still continuous. So that continuous line of energy there is going to tell you that this is a IR spec graph. So that means I need to go to an IR spec appendix to see what it is. And so how do I do this? I am literally going to just compare. What does this look like? So I see that I have a trough here at 3,000, and I have a trough here between 500 and 1,000, and then I have a cool little mountain range thing going on right here. I'm going to look for two troughs and a mountain range that match that. So let's do that. So this is Appendix D, and just kind of right off the bat, I'm just looking for the same shape. So I see that I have a trough here, no trough here, But I do have some troughs here, but that doesn't match. So right away, I'm just going to kind of go past that one. This one has a trough there. Has a cool little mountain range. Has a trough there. So that's your job to go back and see what matches and what doesn't match. This one has a trough. The mountain range is different than the original. So just kind of compare really quick. That had kind of a flatter little range there. This one has more of a spikier range. It's probably not that one. So you're going to go through and match all of these. Of the 8 that I've shown you, there's actually 12 in the textbook, and you're going to figure out which one is it. And then the answer is going to be written for you on the graph. So whatever these little boxes say, that's the answer. So once you find your match, there's your answer. And that's it. So it's pretty much just look up the microcrystalline test that I highlighted in yellow, match the picture, and those are your 2 answers for question 13. For question 14, we are now moving to a different type of test. So we see now instead of the IR spec, we are looking at mass spec. How do we know it's mass spec? Because we see these just straight little lines. We remember that each of these lines are showing us components of the drug that have been blasted apart by electrons. Again, that is in the notes on the video. So we want to understand how that works. If you haven't watched the video, watch that part. So for 14, it says you get a violet blue color with the marquee reagent test that you submitted to your lab. So you did a presumptive test and you got violet or blue or purple, however you want to read that. And so the first thing you want to do is you want to know, what do you think you have? So we go back to our presumptive test. We have our marquee test. And we want to know, what does purple look like? So there's purple. And so we think maybe it's heroin. We're not sure though, because we know from that last video on Edpuzzle that maybe that's wrong. So we want to send it to our lab. So our lab is going to go ahead and produce this using mass spec. And what we find with our mass spec is that we find 2 graphs. So 2 graphs tells us that our drug has 2 things in it. During gas chromatography, because we know gas chromatography always comes before this, it probably had a little graph that looked like that. So it had 2 peaks, peak 1 and peak 2, and we know time goes here. So maybe this peak is this one, and we know that peak is maybe that one. So that means we have to locate 2 drugs using the appendix. So I'm going to go ahead again and just kind of look, eyeball, okay, what do I see? I see a peak at 280, I see one at 160. Are there more? Definitely, but I just want to try to do an exact match, and so by memory I'm going to remember that 280 and that 160, so I'm going to go over to my appendix, and I'm going to cheat a little bit. My other graph had me at 280, so that one only has me at 200, so that can't be right. Oops. So I'm like, okay, not that one. That one has me at 150, so that's probably not right either. So I'm just going to kind of look and eyeball really fast. Which one of these could it be? Oh, this one has me at 300, but there's no peak here at the 280, so I don't see my peak right in that range, so it can't be this one. So I'm going to keep doing that until I find a match. And on the 3rd page here, I do find something that looks like it could be a match. But that'll be your job to figure it out. Maybe it's that one. Maybe it's the one above it. Who knows? But you're going to look for it. And again, when you find an exact match, what's your answer? It's going to be in this box. So whatever these drug names are, that's what it is. And what are you doing? You're just matching. It's an exact match. Then you have your drug. You're going to do that 2 times. One for this one, for component 1. And you're going to do 1 for component 2. And that's it. These are your appendices. For question 16, this is a little trickier. Infrared spectra of butanol, also known as butyl alcohol, and butanol butylaldehyde are given below. Which do you think is the aldehyde? So for this one, this is actually not going to be in your appendix, which is confusing. Instead, it's going to want you to go to page 155. So my big tip for you, go to page 155 to match. So it's kind of similar to what we did before, where we're just matching the peaks and the valleys. But in this case, it's not going to be an exact match because it's asking you which one it's the sister drug for. So we're just going to look for some similarities. We see that this particular one has some dips and valleys that are similar. So we see we could have ethanol here. We can see acetaldehyde, and we see acetic acid. And the question is asking us for aldehyde. So you're kind of doing, oh, well, aldehyde, okay, that looks like aldehyde. And this one looks like acetaldehyde. Those words look alike. Well, yeah, they are alike. And so what you're going to do is you're going to look at these two graphs, graph 1 and graph 2, and you're going to see which one looks the most like the middle one. So this is comparison. They're not going to be exact, but they're going to be similar. So which graph, 1 or 2, looks the most like acetaldehyde, which is this one. And when you find your match, that's your answer. You're just going to say graph 2 or graph 1. Graph 1, just so you guys know, is butanol. And graph 2 is butyl, let's see, butanol. And then the aldehyde. And so you're going to basically tell me which is which. And that's the end of your homework. At that point, you have now answered questions 1, 2, 5, 6, 13, 14, and 16. We're going to be doing something very similar to this on the quiz on Friday. So if you have any questions, please feel free to reach out to me. I can do a Zoom meeting for you guys, or you guys can do a remind, and then we can set up a Zoom. Completely up to you. Or if this is enough, then go ahead and get that homework done. And best of luck to you, and I'll see you next time.